Hi folks, welcome to this video on just some miscellany that may be of some value for Chapter 13 of the Oxford text for Math AASL. So one thing that we know about the unit circle is if you have some angle theta in standard position, the x value of the point on the unit circle is cos theta and the y value is sine theta. And a unit circle means one with a radius of 1. Well, what if you had a circle with a different radius? What if you had just a general radius, r? All that would happen is that all your points would get scaled up correspondingly. So your x value would be r times the cosine of theta, and your y value would be r times the sine of theta, which kind of gives you another way of talking about points in space. We've already talked a bit about higher order derivatives. So here we're looking for the first, second, and 21st derivative of y equals 2 cos x. So I know I'm going to have to differentiate some trig stuff. Off to the side, I'm going to draw my wheel of trig. So I know if I differentiate cosine, I'm going to get negative sine. So in this one, y prime is going to be negative. The 2 will stay as a coefficient, so I'll get negative 2 sine x. And if I get the second derivative, I'll get negative 2 stays and cos x. If I wanted, second derivative. If I wanted the third derivative, well, I'd get 2 sine x. If I wanted the fourth derivative, then I'd put in another jump on this wheel of trig, and I'd be back at cos. Oh my. Be back at cos x. So we could keep going through this till we get to the 21st. Often for these higher order derivatives, we'll write it like this, with brackets 21. Now the question is, where does that leave you on the wheel of trig? So every 4 times I go through this process, I'm back where I've started. So after 4 times, I'll be at cos. After 8 times, I'll be at cos. 12 times, I'll be at cos. 16 times I'll be at cos. 20 times I'll be at cos. 21 times, I'll just need to make one more jump. And the 21st derivative will be the same, in this case at least, as the first derivative. So I'll get negative 2 sine x. So we're looking for patterns, and if anything's going to be cyclical, it's going to be trig functions as they go round and round. I've got a little brain teaser at the bottom here to write an expression for the nth derivative of f of x equals x to the minus 1. But I think we'll just leave that as a question out there for you folks. And that takes us to the end of what I wanted to cover in this really short video on just a couple of issues. Notation for higher order derivatives and coordinates of a point that's on a circle with a radius r that's centered on the origin. I hope this has been helpful. Good luck with the material, folks, and take care.